All right, let's watch. Okay, so you've probably already watched. He climbed 400 feet. That was how high that thing was, which was 136.4 meters. I wish I'd made us convert that. And he probably has a mass of 65 kilograms. I personally think he might have a mass a little bit more than 65 kilograms, but that's okay. Let's see. How much work did he do? Okay, ready? See if you can do that on your own before I go any further. Because I'm not going to calculate this one out. All right. I mean, it's calculated out here on the slide. Well, I guess you have the whole slide there, so you can already see it. But anyway, if you're working this the way I'd like for you to do these things is you'd watch the videos and just kind of work your way through it, just like you would sit in a lecture. Then call up the slides. But again, work times force equals force times distance. The weight times the distance. Ooh, 86,886 joules. That's an energy. Remember, work and energy are the same thing. How much work did gravity do? That answer is not up there. So in the Davos, in the rock climbing, how much work did gravity do? So in the rock climbing, work done by gravity. The force is pulling of 65 times 9.8 is going this way. Okay, but he climbed 136.5 meters this way. So again, anti-parallel, that means the negative 86,888 joules, or whatever it was. And if you add the two together, you get 0. In other words, there's only the energy is conserved. There's only so much energy in the universe. Where it came from, we're not sure exactly. We have the Big Bang down to the billionth of a second of when it started. But between that 0 and that billionth of a second, we're not really sure what happened. And then we've got all this antimatter and dark energy that's out there in the universe that is playing with things on the fringes, and it's really cool. All right, but anyway, I digress. Okay, puzzle. A man pushes a very heavy crate across a horizontal floor. Gravitational work done on the crate. Gravity's pushing down. He's moving the crate. Oh, it's perpendicular. Depends on the way of the load? No. Cannot be without more. Nope. What do you think it is? That'll probably be. I'm almost positive that's going to be on your little mini quiz. Zippity doo dah. There we go. Weightlifting question. All right, here's another one. If the bar is 2.5 meters off the ground, all right, so we're already at this point, and the man at the top is doing 3,000 newtons, how much work is the weightlifter doing? Right at this point, how much work is he doing? I want you to think about that. So, how much work is the weight? I'm going to go to my thing here. How much work is the weightlifter doing? Remember, work is equal to force times the distance. So the weight that he's holding up is 3,000 newtons. But how far has it moved? Times 0. He's not doing any work right now. Now, I will bet $1 to a donut that he feels like he is, but he's not doing what we call mechanical work. All right. Internally, his muscles are flexing, and they're flexing, and so therefore they're moving, they're doing work. He's got blood vessels, oxygen is moving in his body, electromagnetic currents are moving in his body and the other guy's body. All kinds of internal heat and work and stuff like that, energy is being expended. But as far as mechanical work, none. Expect to see that question too. All right, now what is power? I'm going to stop here and we will start with, this guy has complete power over this person. We'll stop here and we'll talk about power in a minute.